So for our trigonometric function video project, we decided to base it off of a tire on a car wheel. But to start, we will explain a little bit of how to graph a function.
So firstly, I'm going to explain how to graph a basic sinusoidal function in the form of y equals a times cos or sine b x minus h plus v. So here we have the basic equation y equals 2 sine 4 x minus 90 plus 2. And now we're going to graph that. Okay, so first we're going to start with our v value, which is our midline. So it says 2. So we're just going to draw a dotted line along 2. And like I said, this is the midline of our sinusoidal function. So now we're going to graph our h value, which is negative 90 in the brackets, but once you take them out, that becomes 90. And our h value is our starting point of our wave. Next, we're going to look here. So this says it's a sine function, not cosine.
So sine starts from the origin, which is here, but if it was cosine, like our tires, it would start from the maximum, or if it was negative, the minimum. So in this situation, we'll be starting from the origin, since it's sine, which is right here.
So now we're going to graph our a value, which is our altitude, or the distance between the midline and our maximum and the midline and our minimum. 2 units above our midline, and then 2 units below will be our x-axis. So now we're going to use our b value to graph our wave. And to do that, we're going to do 360 divided by 4, which will give us 90.
So since one cycle is 90 degrees, and 90 is our origin point, 90 plus 90 is 180. So the end of one cycle is at 180. From here, we can graph it, our cycle. And that is sinusoidal function. We can also find sinusoidal functions in the real world. For example, here we have a tire on a truck that's moving at a constant speed of 7 kilometers an hour. The tire has a height of 74 centimeters and it takes 1.3 seconds to make one full rotation. We marked a point on the tire with chalk to show the starting and ending point of the rotation.
With all this information, we are able to create a trigonometric equation that we can later graph. Firstly, we need the basic trigonometric function of y equals a cos or sine b x minus h plus v, as we mentioned before.
Now let's solve for a, where our a value is our altitude. We can find a by dividing the height by 2. Therefore, if the maximum height of the tire and starting point is 74 centimeters high, then half of that is 37 centimeters, representing a.
Next, our b value is 360 divided by the amount of time that it took for the tire to complete one full rotation. And from the video, we can see that it took 1.3 seconds. So, 360 divided by 1.30 is 276.9, which is our b value.
The h value is the beginning point of the tire rotation, which is 0.
Now for the v value. Our v value is going to be the height of the midline of the tire. So since our minimum is 0 centimeters, which is the ground, and our maximum is 74 centimeters high, that makes our v value 37 centimeters.
Lastly, we need to decide if we are going to be using sine or cosine in our function. We know it's sine if our h value starts at the new origin, and cosine if our h value starts at the maximum or minimum. And so as you can see, the chalk mark starts at the maximum, meaning our equation is cosine.
Okay, let's put all our values together into an equation. That gives us y equals 37 cos 276.9 times x minus 0 plus 37, which can be simplified to h equals 37 cos 276.9 t plus 37. And as you can see, we're using the variables h and t instead of y and x. This is because in our case, our y-axis is actually the height of the chalk mark in centimeters, and our x-axis is the time in seconds.
So our first question is, at what height is the chalk point on the chalk at 0.25 seconds? So if we know that our equation is then we can use the fact that it takes 0.25 seconds to reach the height, and we can solve for the height. So first I will restate the equation inserting t. Then we solve. So firstly, 276.9 times 0.25 is 69. And 37 cos of 69 is 13.26. And finally, our height is equal to 13.26 plus 37 equals to 50.26 centimeters.
Okay, so our next question is, at what point is the chalk mark on the tire 30 centimeters from the ground? So we know from the question that we're going to be using the equation of the truck, which is, we have the height, which is 30 centimeters, and we're solving for time. So now I'm just going to rearrange the question with 30 centimeters. Now we're going to subtract 37 from this side, which gives us negative 7. And next we're going to divide this whole thing by 37. And I'm just going to leave it as a fraction so it's easier to solve later. So now to solve for this, we're going to do cosine inverse of negative 7 over 37. Next, we're going to divide by 276.9 to isolate our variable. And when you solve for that, that comes to 0.36 seconds. So from the work we just did, we got that it took 0.36 seconds to reach the height of 30 centimeters. However, from the diagram, we can see that it took 0.36 seconds to get to this point. And so to figure out how to solve for the time to get to this point, we can take 1.30 seconds, which is the amount of time it took for it to go all the way around, and subtract 0.3 seconds. To get this time right here. Therefore, the chalk mark is 30 centimeters from the ground at 0.36 and 0.94 seconds.
Similarly, we have another vehicle that's going at the same constant speed of 7 kilometers an hour, except it has a smaller tire. Our new equation will be 29 cos times 493.2 t plus 29.
As we said before, to get the b value, we must divide 360 by the time it took to make a full rotation. Therefore, if it took 0.73 seconds to spin once, then 360 divided by 0.73 equals 493.2, which is our b value.
Our h value is not shown in our equation because it has a value of 0. This is because our function starts at 0 seconds.
We know our v value is 29 because the midline of the tire is half of the height of the tire in our case, which is 29 centimeters. Our a value is 29 because from the midline to the maximum height of 58, it's 29 centimeters, and from the midline to the ground, it's also 29 centimeters. Lastly, our function is cosine because it's starting from the top, or the maximum, rather than the midline.
This graph accurately shows the two vehicles' tire rotations as they make continuous cycles where the red represents the truck and the blue represents the car.